Right, so it says, what is the volume occupied by 3.5 moles of nitrogen gas at STP? What is the volume occupied by 3.5 moles of nitrogen gas at STP? All right. But maybe before I do that, let me just see. Yesterday, he's reminding me here, I was supposed to show you how to convert my units. All right, how to convert the units. So that's what I want to do today. All right. You see there? Okay. Starting yesterday's story again. Okay. And then what happened? I don't know what's happening here. The moment I move my laptop, then everything. So check my camera. Okay. Right. Right. So when you're converting, this is what you do. The units, they go like this. You've got your king, Harry, died miserably, disease, cold, malaria, right? Right, King Harry died miserably, disease called malaria. Right, so here we are talking about length. We're talking about length. Yeah, so we've got length, area, and volume. We did that. Right? So basically what you have, you've got your step there is 10, and this is kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter. And the step here is always 10. Step is 10, step is 10, step is 10. All right, when you move from big to small, when you go that way, you multiply. When you move from small to big, you divide. So when I move from millimeter to centimeter, I divide by 10. If I move from millimeter to decimeter, I divide by 10 squared, because it's 10 to the power 1 times 10 to the power 1, so it's 10 squared. It's going to be 100. If I move from millimeter to meter, it's going to be 10 to the power 1 plus 10 times 10 to the power 1 times 10 to the power 1. Rules of exponents, it means I'm going to add my exponents here. It's going to be 10 to the power 3, which becomes 1,000. Is that clear? All right, then that's your length. You move on to your area. Area, we know it's length times breadth. So the units are square. They're always square units, right? So you're going to have again, King Harry died miserably, disease, cold, malaria. So you've got your kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter. All right, the units now here, they are, we had 10 for area, it was 10, the steps. Now the steps are going to be 10 squared, which is 100 square. You're squaring everything. And your units also are now square kilometer, square hectometer, square decameter, square meter, square decimeter, square centimeter, square millimeter. Again, when you move from big to small, that way you multiply. When you move that way, you divide. So when I move from square millimeter to square centimeter, I'm moving from right to left. So I'm going to divide by 10 squared, which is 100. If I move from square millimeter to square decimeter, it's going to be 10 squared times 10 squared. The rules of exponents, it becomes 10 to the power 4. 10 to the power 4 makes it 10,000. If I move from square millimeter to square meter, I'm making 3 steps. 1, 2, 3. Each step is 10 squared. So I'm going to have, my power is going to be 2 plus 2 plus 2, which is 6. 10 to the power 6 is a million. So when I change from square millimeter to square meter, I'm going to divide by 10 to the power 6, which is a million. Is that clear? Right. Then I move on to the next one, volume. Volume. I've got volume is length times breadth times height. So it's going to be cubic units. So I still have my King Harry died miserably, disease, cold, malaria. So you've got your kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter. And because now it's cubic, my units here now become cubic kilometers, cubic hectometer, cubic decameter, cubic meters, cubic decimeters, cubic centimeters, cubic millimeters. My step here is going to be 10 cubic. The step now is 10 to the power 3, which is 1,000. The step is now 10 to the power 3, 1,000. When I move from right to left, I divide. When I move from left to right, I multiply. So when I move from cubic millimeters to cubic centimeters, I'm moving from right to left, I'm going to divide by 10 to the power 3. What is 10 to the power 3? It's 1,000. When I move from cubic millimeter to cubic decimeters, I'm making 2 steps, 1, 2. Each step is 1,000. So 1,000 times 1,000 gives me 1 million, which is 10 to the power 6 if I just add the exponents. So when I move from cubic millimeters to cubic decimeters, then I'm going to divide by a million. If I move from cubic millimeters to cubic meters, I'm going to make 3 steps. 1, 2, 3. So it's 3 plus 3 plus 3, which is 9. So my answer is going to be 10 to the power 9. I'm going to divide by 10 to the power 9. What is 10 to the power 9? That's 1 billion. Is that clear? All right, if I move from cubic meters to cubic millimeters, I'm going to multiply by a billion. Clear? Then please note, cubic millimeter is the same as milliliter. And cubic decimeter is the same as a liter. So whenever you see a liter, it's the same as cubic decimeter. Whenever you see milliliter, it means it's a cubic centimeters. Yes? No, it's volume. Cubic centimeter means 1 centimeter length, 1 centimeter breadth, 1 centimeter height. It's the space covered by breadth of 1 centimeter, a length of 1 centimeter, and a height of 1 centimeter. Okay, let's start from here. Understand here. Length means distance, like between me and you is distance. That's length. That's why you have kilometer, hectometer. When we say area, area means what? What is area? It means the space covered. Space. Are we together? Like between you and me is not space, it's distance. By space means like the front top of the table. How much area, how much space is covered by this top of the table? So it's your length and your breadth. That's the space. If I'm going to tell this room here, what do I need to know? Do I need to know length or space? Space, because the tile comes with the length and breadth. When I put it down, I want to know that space, how much space will that tile cover? Now we go to volume. Volume is capacity. How much substance can you hold? How much liquid can you hold? That's capacity. So on the table here, if I pour water here, will this table be able to hold water? No, because capacity, I need the sides so that the water can be contained in. That's capacity. So by volume, volume we mean capacity. If I'm to pour water here in this room here, how much water will be taken by this space here? That's capacity. Are we together? So that's when we speak about volume. So for volume, we need length, we need breadth, we need height to withhold the water so that the water does not flow away. Clear? All right, so centimeter will never be the same as cubic meter. It will never be the same. Neither will it be the same as a square centimeter. It's not the same. Okay, so that's what we have on that particular calculations. Please make sure you understand this. The one that we're going to be using now, it's maybe cubic centimeter to cubic decimeter. So that step is 1,000. We're not going to be use 100. We're not going to be use 10. We use 10 to the power 3. All right, so that's what we're going to be dealing with. Please note, liters is the same as cubic decimeter. So in the exercise that I gave you yesterday, there were liters. So wherever you have liters, it simply means the same thing as cubic decimeter. Is that clear? Right. Let's move on to that activity now. Okay. Let's look at the corrections. Let's look at the corrections. Number one. Number one, what does it say? It says, what is the mass? What is the volume occupied by 3.5 moles of sodium of nitrogen gas at STP? What is the volume occupied by 3.5 moles of nitrogen at STP? So where do you start? What are you given? You start with what you're given. What are we given? We're given number of moles. STP. The moment you see STP, what do you recognize here? Molar volume, isn't it? You recognize molar volume. Molar volume, what is molar volume? 22,4 cubic decimeters, yeah. That's what you recognize here, isn't it? Right, STP, obviously, we know it's 0 degrees, 1 atmosphere. Right, now we need volume. Which formula are we going to use? Number of moles is equal to V over Vm. Number of moles is how much? 3.5. Is equal to V. We are looking for V. What is your molar volume? Your molar volume is 22.4. And this is over 1. Then you cross multiply. When you cross multiply, what are you going to get? Volume is equal to 3.5 times 22.4. What's your answer? 78.4. 4. And what are your units? Cubic decimeter. Right, when you mark, how do you mark? Right, 1 mark for formula, 1 mark for substitution, 1 mark for the answer, 3 marks. Yes. You didn't write that? On the final answer. Yes, it becomes wrong. So you're going to get 2. Always your answers must have a unit. It's DM cube. How do you know it's maybe you're using cubic centimeters? How do you know maybe you're using cubic meters? So if you have units, so you're going to get 2 out of 3. 2 out of 3. All right. Are we done? Can I move on? Right. So the next one, I'm going to erase here, delete. Right. So we move on to the next one. What mass? We are looking for M of nitrogen gas. So we know the formula for the substance we're talking about. Occupies a volume of 11,2 at 0 degrees and 1 atmosphere. That's STP. So they've written it differently. They've said at 0 degrees, they've defined the STP. STP is 0 degrees and 1 atmosphere. So it's still the same as at STP. At STP, what do we know? We know, what do we know? We know molar volume is 22,4. But here we need mass. But for mass, what equation do we use? We use number of moles is equal to mass over molar mass. We are looking for mass, all right? But do we have the number of moles? Do we know the number of moles? No. Do we know the mass? No. Do we know the molar mass? Yes, we can find the molar mass. Molar mass for what? For nitrogen. Nitrogen on the periodic table, what is it? It's 14. It's going to be 14 times 2. That's all we have. We don't have mass. We don't have number of moles, so we start. So we need to get at least 1 out of this so that we're able to find the mass. So what are you going to do? We go to the other information that was given. What are the information that was given? We are given volume. So we're going to use the equation. We're going to use number of moles is equal to volume over molar volume. All right, we substitute. The volume was given 11,2 liters. A liter is the same as a cubic decimeter. So we're going to write here 11,2 over 22,4. So the units are the same. So there's no need to convert. We divide the 2. What do we get? We get 0,5. So our moles are 0,5. Now we've got the 0,5. Now we take this and we're gonna put it here. You take your 0,5 and we put it here. Now we have number of moles. So we're gonna substitute. Now that we've got number of moles, we're gonna substitute 0,5 is equal to mass over molar mass. Molar mass, which is 28. You make your subject of the formula M. So your M is going to be equal to 0,5 multiplied by 28. 0,5 is half. So half of 28 is 14. So your answer is 14 grams. That's how you get your answer. How do you mark this? You're going to get a mark for mass. You're going to get a mark for formula, mass over molar mass. All right, mass, formula for number of moles for V over Vm. 1 mark for substitution, you're not going to get for the answer because you still have to use it. You'll get it here where you do the substitution, and 1 mark for the final answer. So you're going to have 5 marks for number 2. You're going to get 5 marks. So number 1 was 3, number 2 is 5. So it's 8 so far. Clear? Now move on. Right, we go to number 3. How many moles of a helium gas should be placed in a piston so that it expands to fill a volume of 56 liters at STP? So here what we have, we're given what? Volume. And STP, what do we get? Molar volume. So we can find the number of moles. So what equation we're going to use? Number of moles is equal to V over Vm. Right? This is number 3. Our volume, liters, is the same as cubic decimeter, so we don't need to convert, so it's going to be 56, 8. Divide by molar volume, which is 22,4. What's your answer? Two comma 54. So your answer becomes 2,54 moles. You the same. Five three. What is the number after the 3? Yeah, you round it off. It becomes 2,54. All right. Then here the marks are gonna get 1 mark for formula, 1 mark for substitution, 1 mark for the answer. That is number 3. That is number 3. That is your number 3. Right, I move on to the next one. Number 4. Right, for number 4, let's look at this one. It says 35 grams, so that's mass, of an unknown gas occupies a volume of 11,2 liters at STP. So we know we are given mass, we are given volume, we are given molar volume STP. It's telling us use molar volume 22,4. Scientists suspect nitrogen, oxygen, chlorine, and hydrogen. Which one is likely to be? Or which one is it likely to be? Is it any, which one out of these 4 is likely to be this gas here? So where do we start? We are given mass, all right? So we're given mass, and the question is saying, which one is it likely to be? For me to determine which one it is, what do I need to find? Huh? Number of moles. But number of moles, if I have got 5 moles, do I know it's nitrogen? Which one is it likely? How do I compare? I compare it with what for me to come up with that conclusion? With the? But when I calculate here, I'm not going to get volume. I'm going to get what? A number of moles, isn't it? How do I link the two? Yes? Okay. Yes. Was the correct one. Okay. So basically you're looking for the molar mass. What you can do, you can calculate the molar mass. We are looking for molar mass here. Then we compare which one is good. The same molar mass is the answer that we're going to get. Is that understood? Right, so I start, I'm given mass. So once I'm given mass, what do I know? I know it's number of moles is equal to mass over molar mass. I don't have number of moles, so I'm going to substitute. I'm going to substitute here. My mass is 35. The molar mass, I'm just going to keep it M. But I don't have number of moles. So where do I get the number of moles? I'm going to use volume. Number of moles is equal to volume over molar volume for me to get my number of moles. My volume, what is my volume? I'm given 11,2 liters, so it's going to be 11,2 divided by STP, it becomes 22,4. When I divide here, I get 0,5 moles. Now that I've got the moles, I'm going to take these moles and substitute it here in this equation. All right? So I'm going to substitute here. Where I don't know the number of moles, now I've got 0,5 is equal to 35, which is the mass that I was given, divided by the molar mass. I need to find the molar mass. So this is going to be over 1. So my molar mass, I swap those two, it's going to be 35 divided by 0,5. What's my answer? My answer is 70. And this becomes grams per mole. This becomes grams per mole. Now I'm going to take this 70 and check from the substances that are given, which substance has got a molar mass of 70. So I start. Nitrogen, I know it's 14, and it's N2, so I multiply by 2 because it's a gas. 14 times 2 gives me 28. Do I have 28 here? No. So nitrogen is out. It's not nitrogen. I go to the next one. Oxygen, the molar mass on the periodic table is 16, but this is a gas. 16 times 2 gives me how much? 32. Do I have 32 here? No, it's not oxygen. I go to the next one, chlorine. Chlorine is 35,5. 35,5 times 2 gives me 71. Do I have 71 here? No, but it's close, isn't it? Right? It's closer. So this could be the likely possibility. I go to the next one, hydrogen. Hydrogen, how much is it? 1. 1 times 2 gives me 2. I don't have 2. So my likely contender here is chlorine. So the answer is chlorine. So you write, therefore, the gas is chlorine. It is chlorine. So the answer is chlorine. Right, so when you mark, you're going to get a mark for the formula, mark for the substitution, mark for the V over Vm, mark for the substitution, mark for the answer, mark for the conclusion. To say it is chlorine gas, you're going to get a mark. So this question is going to give you 6 marks. 6 marks. It's going to give you 6 marks. So the answer is chlorine. Answer is chlorine. All right, I move on to the last one. Can I rub here? Okay. Right, the next one is this. What volume would the following amount of gas occupy at STP? All right, so we start. 2 moles. So we're going to use our formula. We are looking for volume. So we need a formula for volume. Number of moles is equal to volume over Vm. Right, so if I need volume, I simply cross multiply. Volume is equal to number of moles multiplied by molar volume. So the first one, I'm just going to multiply 2 times 22,4. So here I simply multiply n multiplied by 22,4. Simply multiply by 22,4. So 2 times 22,4, what do I get? 44,8. So the answer is 44,8. You get 2 marks for this. Next one, 0,1. I simply multiply 0,1 multiplied by 22,4. What's the answer? 2,24. Cubic decimeters. Please don't forget the units. Cubic decimeters. 2 marks for this. Next one, I've got 5,5 moles. It's going to be 5,5 multiplied by 22. What's the answer? 123,2 cubic decimeters. 2 marks for this. All right, then the last one. We did this in class. Did we do this? No. Okay. All right, let's do this one. For this one here, we've got 2,4 grams of ozone. So here I'm given mass. So I need to first find the number of moles. So I'm going to find the number of moles of ozone. Number of moles is equal to mass over molar mass, which is equal to the mass is 2,4 divided by the molar mass of ozone. What is ozone? Ozone is O3. Oxygen is O2. Ozone gas is O3. Right, so I'm going to divide by 16 times 3, 48. Right, which is equal to, what's the answer? 0,05 moles. Right, after I've done that, I go to my formula for volume. Volume is number of moles is equal to volume over Vm. Over Vm. My number of moles is 0,05. All right, you've got your V over molar volume. What's your molar volume? 22,4 at STP. Your volume now is equal to, what's the answer? 1,12, okay? Cubic decimeters. All right, so when you mark, 1 mark formula, 1 mark substitution, 1 mark formula, 1 mark substitution, 1 mark the answer. 5. 1 mark. Get to answer. Yes. Here you are given mass and we need volume. So first you need to get the mass. You need to get the number of moles. So you're going to say number of moles is mass over molar mass. So you're going to take your 2,4, which is the one that you've given here, divide by the molar mass of ozone. Ozone's formula is O3, and it's 3 oxygens. So it's going to be 16 times 3, which gives you 48. Then you've got 2,4 divided by 48 to give you 0,05. Now you have the number of moles. You haven't answered the question. The question wants volume. So now after that, you go to the formula V over F Vm because it's at STP. So you're going to say number of moles is equal to volume over molar volume. Your number of moles, you take the answer that you got here, you put it here, is equal to volume over molar volume, which is 22,4. So you substitute, then you make it V the subject. So you cross multiply. The answer becomes 1,12. All right, next one. The last one, you do the same thing exactly. Just the difference is going to be your molar mass is going to be different. So here you're going to still use number of moles, mass over molar mass. So it's going to be 0.08, 0.88. I'll just write the answer. You're still using the same formula. But here you're going to use 0.08, sorry, 0.88 divide by molar mass of carbon dioxide, which is 44. What's your answer? Answer is 2 moles. No, no. 0.02. After you get to 0.02, you go again to this formula here. Then you get your volume. So your volume is going to be equal to 0.02. I'll just do the final answer here. 0.02 multiplied by 22.4. So your answer is 0.448 cubic decimeters. You also get 5 marks. So it's mark formula, substitution, answer. Formula, substitution, answer. So your total is going to be, here you've got 5, 10, it's 5, 10, 12, 14, 16. 5, 10, 12, 14, 16. Then I have to count the top. Can I wrap here? Huh? Okay. So it's 5, 10, 12, 14, 16. 16 plus 6, that's 22. 22 plus 3, that's 25. 25 plus 5, that's 30. Plus 3 is 33. Your total is 33. Give a total out of 33. 33. Give me a total there. Okay, any questions? Any questions? Right. Yes. Yeah. 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 Formula for ozone. I think they'll give you the formula. If you don't know it, they'll give it to you. Yeah. Especially for these substances that are not common, they'll give it to you. Right. Let's move on to today's lesson. Today's lesson, we're looking at stoichiometry calculations. These are calculations now using everything that we've learned from the 4 formulas that we've been doing. All right. Learning all of that, we now need to apply that and solve problems. Right, so let's start with the definition for stoichiometry. Basic stoichiometry calculation. Stoichiometry is the calculation of the quantities of reactants and products in a chemical reaction. All right. Stoichiometry is the calculation of quantities of reactants and products in a chemical reaction. Stoichiometry is a calculation of quantities and reactants and products in a chemical reaction. Right? It is important to know how much product will be formed in a chemical reaction. or how much of a reactant is needed to make a specific product. All right. So basically, what are we saying here? If I've got, let's say, 2 kgs of flour, I want to bake some muffins, right? I want to know this flour, if I'm in a business of selling, baking muffins, I want to know this 2 kg, how many muffins is it gonna make? So you can work from flour to muffins, or you can work from muffins to flour. Like I want to cater for 100 people. How many each person must get muffins, right? So how much flour do I need? So you're working from flour, you're not working from muffins to flour. And you need to work the other ingredients as well, the eggs that I need. What ingredients you're gonna need? You're working from the product to the reactant. Or I've got so much flour, how many muffins can I make out of this? So you're starting with your reactant, you wanna see how much product you're gonna produce. So this is what we're talking about. So this is basically what we do when we're calculating stoichiometric calculations. Right, so you don't have to copy this. I'm going to post this on Google Classroom. So yeah, let's just understand what is happening here. So I will be, in my problems, I'll be given any one of this, including concentration. So I didn't include concentration here. You can still have concentration here. Right, but the division sign is not going to work for concentration. It's going to be the opposite, actually. Right, and there's no constant in concentration. That's why I don't have this. So all of these, molar mass, it's a constant for that particular substance. Avogadro's is always a constant. Molar volume, 22.4 cubic centimeter or liters, is always a constant. Right, so if I'm given mass, number one, before I can do anything, I need to convert it to moles. How do I convert it? I need to divide by molar mass of that particular substance. If I'm given particles, I must divide by Avogadro's to get moles. So moles is the central thing that we compare substances. If I'm given volume at STP, I need to convert it to moles. If I'm given concentration, let's say I've got concentration here. If I'm given concentration, then what am I going to do to get moles? I know number of moles is equal to concentration times volume. So you see here, it's a times, not divide. That's why I don't have concentration here. Clear? All right, so if I'm given concentration, for me to find number of moles, I need to know the volume of that particular substance so that I take that concentration times the volume. Clear? All right, so this is going that way. When I come this other way here, if I go out like that, all right, what am I going to do? Right? For me to get concentration, what am I going to do? I'm going to take the number of moles here and multiply it. Number of moles is equal to concentration times volume. Sorry, I don't need this. It is changed here. For me to get concentration, I'm going to say number of moles divided by volume. So you see here I multiply to get number of moles, but here I divide, so it becomes the opposite of these two signs here. That's why basically it's not here. Right, but it's one of the ways that you also be given. So if I've got concentration, I must find number of moles. If I need concentration, I have to divide the number of moles divided by the volume. These moles here, these are the moles. There are two things that we have here. It's a mole ratio. So I would compare the number of moles of given versus what I want. So there's a mole ratio involved here. I'll explain that as we go, as we proceed. Right, so let's carry on. In this subsection, we'll bring together all the quantities and calculations that have been dealt with in the entire section and apply them to calculations involving chemical equations. So here now we have a balanced equation. Some points to note: calculations using all aspects of molar quantities. Right, when doing calculations from chemical equations, you must first ascertain that the equation is balanced. So you're going to have a balanced equation. Make sure that equation is balanced. If it's not balanced, balance it. Otherwise, you're going to work with the wrong ratios of moles. The coefficients in front of the chemical formulae and symbols, that is the balancing numbers, represent the number of moles of each substance present in the reactants and the product. Example, what do you mean by this? If I look at this, sodium hydroxide reacts with H2SO4 to give sodium sulfate and water. What is the ratio of the moles? The ratio here is 2 is to 1 is to 1 is to 1. So what are we saying? We are saying 2 moles of sodium hydroxide react with 1 mole of H2SO4 to give 1 mole of sulfate to give 1 mole of water. Those are the moles that we are talking about. These coefficients, those are the moles that we are talking about. Right. So here the ratio is 2 is to 1 is to 1 is to 2. So for every 2 here, we need 1. And for every 2 here, we produce 1 sodium sulfate. For every 2, we produce 1 water molecule. Those are the ratios that we're talking about. Okay. All right, we go back to the explanation there. So those are the coefficients. The coefficients in front of chemical formula and symbols, the balancing numbers represent the number of moles of each substance present in reactants and products. Right. The coefficients represent the mole ratio in which the reactants combine with each other. So like we saw, there's 2 is to 1. For every 2, we need 1 sulfuric acid. This does not mean that there will always be a number of moles that correspond to these numbers. However, the ratio in which they react will never change. For example, what I'm saying, for example, when you're baking, for every, to give the example of maybe for every 2 kg, I need I need how many eggs? I need 4 eggs, or maybe that's too much. And let's say for every 2 kg, I need 1 egg. Are we together? So if I've got 20 kilograms of flour, how many eggs do I need? For every 2 kilograms, I need 1 egg. For 20 kilograms, how many eggs? I need 10 eggs because 2 is to 1. So if I've got for 2 is to 1. So whatever mass I have, I need half the number of eggs. So if I've got 20, I need how much? I need 20 divided by 2, which is 10 eggs. For every 2 is 1, isn't it? Are you following? What if I've got 7 eggs? How much flour do I need? For every 2 kilograms, it's 1 egg. If I've got 7 eggs, how many kilograms? I need 14. 7 times 2. Are you following? That's what we are doing here. We are using ratio. Right, next one. The mole ratio is carried through to the products as well. So you can compare mole ratio of reactants and products. So I can compare the one that is a reactant to the one that is a product. From the numbers of moles in the mole ratios, we can calculate the masses involved in the reactants and the product. So I can calculate the number of moles for anything. It can be reactants or it can be products. And I can use anything. I can use concentration, I can use mass, I can use number of particles, Avogadro, I can use volume. You need not calculate the masses of everything in the balanced equation. You only answer what is been asked. Because I can calculate anything. So once I have got the moles, I can get anything. So don't do everything. Just answer what has been asked so that you don't have confusion. Or you can go one by one. Right. You should not calculate the number of moles of any reactant that is not given in moles. The next step is to determine the number of moles of the product that you are required to find. Finally, then you can find your mass, you can find your volume, or you can find your concentration, depending on what the question wants. So this is a map again, the mole map or the stoichiometric map. If I'm given number of particles, I must find number of moles. What do? I'm going to divide by Avogadro's number. If I'm given mass, I divide by molar mass. If I'm given volume, I would divide by molar volume. Then I get the moles. Once I get the moles, then I go to my balanced equation and do the mole ratio. 1 is to 2. Then I get the moles of the substance that I want. The moment I've got the number of moles of what I want, then I can answer the question. So the question is going to ask you, what is the concentration? What is the mass? What is the volume? Now, the moment I've got the desired moles, then I can use my equation to get the volume or mass or number of particles or concentration, depending. So on the left-hand side, you're going to divide by those constants. Then you do your mole ratio. Then on the other side, you multiply. All right, let's look at this example here. Sodium hydroxide solution reacts with sulfuric acid to produce sodium sulfate and water according to the following balanced equation. All right, so it's balanced already, so we don't have to balance. You can just verify if you want. You can just check sodium here 2, sodium here 2. Oxygen is 2 here, and oxygen here is 4. 2 plus 4 is 6, and here you've got 4. 4 plus 1. This equation is not balanced, so there must be a 2 here to balance the oxygen. All right, so your sodium here, it's, oxygen is 2, oxygen is 4, so 2 plus 4 gives you 6, and here you've got 4 plus 2, it gives you 6. Hydrogen is 2 plus 2, which is 4, and here we've got 2 times 2, which is 4. Sulfur is 1, sulfur is 1, so everything is balanced, so there's a 2 missing here. Clear? All right, so the ratio is going to be 2 is to 1, is to 1 is to 2. So when I compare sodium hydroxide and the sulfuric acid, the ratio is 2 is to 1, because there's a 1 here. When I compare sodium hydroxide and sodium sulfate, the ratio is 2 is to 1. When I compare sodium hydroxide to water, the ratio is 2 is to 2, which is 1 is to 1. So if here it's 0.5 moles, here it must be also, the quantity must also be 0.5. Right, okay. We'll move on to the next one. So it says here, if 20 grams of sodium hydroxide react completely with sulfuric acid, calculate the mass of sodium sulfate produced. Where are we starting? It's always, okay, you guys online, please, if you get cut off, we're going to have to rejoin. We left with 1 minute, 30 seconds. We'll have to rejoin, but I'll continue so long. All right. So what are you given here? We are given, what are we given? We are given the mass. So I've got mass here for sodium hydroxide, 20 grams. And what am I supposed to get? I'm supposed to calculate the mass of sodium sulfate. So I need to calculate the mass of this sodium sulfate. I need the mass. So I need to move from sodium hydroxide to sodium sulfate. But what do I know here? I can find the molar mass here for sodium sulfate, sodium hydroxide. So I can get this, which happens to be how much? 23. You don't use these 2 here when you're calculating molar mass. You only use NaOH. So it's going to be 23 plus 16 plus 1, which makes it 40. So I've got 40. Therefore, I can find the number of moles here. How do I find the number of moles? Number of moles is mass over molar mass, 20 divided by 40, which gives me 0.5. So I can find 0.5 here, the moles. This is not what I want. This is what I'm given. I'm going to use what I'm given to calculate what I have been asked.